Okay, today we're going to be talking about molecular farming. It's an exciting approach in the alternative protein space that uses plants as bioreactors to produce high-value proteins sustainably and at scale. And joining me is Meir Wachs. He's the founder of Kyomei, a company harnessing this technology to create functional proteins for food applications. We'll be diving into the company's unique approach, the challenges of scaling molecular farming, and what the future holds for this promising technology. Meir, welcome to Protein Production Technology International.
Thanks so much, Nick. Much appreciated.
It's great to have you here. Let's start by setting the scene. For those of our readers, listeners who might not be familiar, could you just tell us a bit about your company, what it does and what is the mission driving your work?
Yeah, so we're a biotechnology-powered startup, really transforming crops into biofactories for a whole wide range of valuable food ingredients.
Mhm.
I'm focused on protein. So we're basically, in a simple man's terms, we grow proteins in plants. That's what we do.
Uh-huh. Now, molecular farming is such a fascinating area. So what inspired the company to pursue this approach, and what gap do you see it filling in the broader biotechnology or food production landscape?
I think at its core, we just saw a whole world of companies using very complicated technology or very complicated, costly downstream technology or upstream technology in the sense of using bioreactors and very lab-based approaches to create food. And we thought there may be a better way to do this, to use plants as a production platform as opposed to more bioreactor sort of approaches.
Yeah, it certainly
More
seems to be
natural,
more
more
cost effective.
connected to agriculture and say, hey, wait, can we transform our existing system rather than creating a new system out of vats? So
Mhm.
that was the initial uh, mind experiment about how to think about this.
Mhm. Now, May, I'd love to hear about your journey as well. What led you personally to get involved in this space, and what drew you to launching the company?
Yeah, so I'm not a plant scientist at all by training. I have no background in plant science. My background's in entrepreneurship. I've been starting companies since a young age. I started my first company when I was 20 in the US and sold it a few years later, and then a number of times. And then I took, a long hiatus, basically. That's how I ended up in England, ended up in school studying, philosophy and theology and things of that nature. And I got a bit bored and I got a bit hankering for a new challenge. And I was
Mhm.
looking for something that could have more profound impact, more wider impact. I didn't want to just sell widgets again. I sell widgets well, made a lot of money selling widgets. I wanted selling more meaningful widgets, if you will. So that's really what drew me to interesting spaces and ways to make a more global impact. And then in Oxford, where I ended up running into my co-founder, who was MBA, MA, PhD in plant sciences, and together we kind of brainstormed and came up with this idea.
It's always interesting to hear what drives founders and leaders such as yourself. So, for you, what's been the most exciting part of building the company so far?
Learning, I love to learn. So for me, I think it's been a fascinating learning experience, if nothing else, an absolute mind expanding journey. I think the complexity of taking really fundamental advances in science, fundamental advances in biology, working with a world-class team. We really recruited an amazing team on the science side, and to really think about how those breakthroughs can be transformed into commercial viability. It's just a fascinating challenge. It's really a fascinating. I love it. I love to think it through. So it's been definitely the most rewarding.
Well, if you don't mind, we're going to dive into the technology side of things now. There's a lot of thought that goes into selecting the right plant species for molecular farming. So, what specific plants are you using, and what made them stand out compared to other options that you might have analysed?
Yeah, interesting. So we actually use leafy greens. We use leaves. We use leafy greens, which is kind of different than a lot of other like the farming companies focus on soybeans or other sort of cash crops.
Mhm.
Um, we wanted to focus on edible crops. And we also wanted to focus on potential waste streams. So from existing crops that exist that have quite a bit of waste streams. I think that kind of differentiates us as well. So we're very much focusing on edible leafy greens, edible crops that have wide leaf matter.
Mhm.
Um, and that's for a wide variety of reasons, but that's been our focus to produce food ingredients for the food industry.
Mhm. Diving down into some of the technical aspects, how exactly do you introduce target genes into your host plant? So you're able to walk us through the vector system and transformation methods that you use?
Yeah. So generally speaking, in plant transformation, you basically have biolistics and you have agro as a very general rubric of how you go about transforming plants. We tend towards biolistics just because we focus on the plastid. So it's just a more effective method of doing that. But that said, we really use both. We use a wide variety of different things. We transform different parts of the plant, so it's not like only one thing. But as a general comment, I would say we focus on biolistics and focus on the plastid.
Mhm. Now, protein purification, that's a critical step in the process. So how do you go about extracting and refining the target protein? I'm also curious, how do your methods stack up against more traditional processing techniques?
That's the $1 million question. I mean, that's really the crucial question that a lot of people don't ask. Everyone's focused on protein expression, but the real question is, how do you actually get it out profitably, and then what means do you do so? Mm-hmm. So we developed our own in-house downstream process. We developed it ourselves, obviously built on other protocols and other people's ideas over decades of people working on bioprocessing. So we have our own bespoke reagents, our own bespoke buffers that we've work best. We very much focused on a downstream process that is optimized for our protein and the kinds of proteins we want to extract. One of the things that we do, and we'll maybe get into it in a bit, is we actually co-extract multiple food ingredients. So we're not just producing one molecule of interest and the rest of it goes to the trash. We're very much trying to focus on extracting multiple products from the same plant. So we built an extraction process that really allows us to do that. How it differentiates it from standard bioprocessing is an interesting question. I think I don't know if there is a standard bioprocessing, but let's say this: like in pharmaceuticals, there's a lot of focus on chromatography because you're obviously focusing on one specific molecule. In large scale, I don't know, you could say just general food protein, let's say pea protein, right? So using acid precipitation, you're using a lot of methods that will denature the protein because you don't really care about the protein being denatured. Our approach lies somewhere in the middle because we want to extract food grade protein. We don't want it to be expensive. We want it to be scalable. And we also want to keep some of the structure of the protein. So we don't want to just, denature the whole thing. So it's somewhere in that middle ground. It's maybe the best way to differentiate where it stacks up in the bioprocessing world.
Now, optimizing plant expression systems, it sounds promising but challenging. In your experience, what have been the biggest bottlenecks when comparing, I don't know, plant-based systems to microbial or animal cell-based production?
Time. Time. That's simple. I think the promise and peril of molecular farming has always been, the promise is that this ability theoretically of having infinite scale, right? You can scale as big as the agricultural system can take you, at least if you're in open fields. The peril has always been obviously, like how long it actually takes you to get a product to market, how long it actually takes you to, develop the right, I guess you could say variety and then integrate it into a germplasm. It just takes a long time. Plant regeneration is not a quick thing to do. There's various ways you can speed it up. And many people try different ways to speed it up, but it still remains a bottleneck, I think. It's certainly compared to precision fermentation, where you can turn around this, really quickly. So that is and of course, time is money, right? So there's no question that is a big challenge, and it takes a long time to see real results. Of course, when you do see them, it does have, almost a transformational impact. Could have a transformational impact.
Now, this molecular farming space, it's growing quite fast. I was quite surprised to see how many companies there are out there at the moment, but every platform has its own spin. So what do you think truly sets your company's approach apart from others in the sector?
Yeah, I can't speak for everyone. I don't know everyone in the molecular farming space and what they're doing, but I think our approach is, interestingly, it's very integrated. We've integrated the downstream very much into our upstream. So we started off just in the upstream, and we really focused in recent years, really very much on integrating the downstream. So I think we built our downstream to optimize our upstream expressions. We've already achieved, and vice versa, right? So we think about our upstream in terms of the downstream. So I think it's a very integral part of our platform. I think the second area is we attempt and we do extract multiple fractions of protein from the same plant. So we don't see ourselves as, we're just trying to make molecule X or molecule Y from, lettuce or something. We look at really as our ability to transform the plant into a biofactory from multiple food ingredients. Some of those are transgenic and some of those are not, right? So some of them are, not only our secondary metabolites, but also our actually just plant proteins. So we have products going to the market this year that are not transgenic at all. They're just derived from our downstream process that's optimized for both transgenic inserted proteins and proteins that are native.
Mhm. Well, you move me on to the next subject there. Validation from the market is always a big milestone for startups. Have you had any real world wins so far? Maybe
So
collaborations
we've
with?
done a lot of collaborations. We've been really excelling a lot of different collaborations with large CPGs, with startups really all over the globe. Publicly, I can say, yeah, we've collaborated with Mondelez RSSL. We've collaborated with University of Cambridge,
Mhm,
startups like Lipid in Taiwan, other large CPGs, some of the largest pharma growers in the UK and Europe.
mhm.
So we have done quite a bit of collaborations.
Now, scaling up, that's often where things get tricky. So, what were some of your biggest hurdles when you moved from that lab scale proof of concept to sort of field scale production, and how have you navigated those successfully?
Yeah, so scale is big on the downstream, obviously. So, buffers, reagents, approaches that you may use on a lab scale or even a small pilot scale don't necessarily scale up uneconomically, or don't necessarily scale up on a commercial basis. So there's a lot of tweaking, a lot of shifting, a lot of changing, a lot of learning, and figuring out, what are the trade-offs between actually being able to scale in a massive way and supply chains and things like that, and then of course, actual getting product to the market.
Mhm. Now, looking ahead a bit, molecular farming, it seems to have real potential for addressing food security and sustainability. Where do you see the technology heading in the next 5 years, especially in those areas?
It very much depends on I think what we see in the market and companies that come out with commercial wins, right? So it's a long process. I think molecular farming fundamentally has the power to transform agriculture, full stop, right? We can go, at least in Kyomei's process, we can go from like a one crop, one product model to a one seed, one product model to a one seed, multiple product, multiple value stream model, which has the ability to just transform land use, to transform agricultural, full stop. Will it happen in the next 5 years? I don't know. There's issues of regulation. So some of the molecular farming has a particular um, complex regulatory challenge, is that you're dealing with both the farming side. So like in the US, you're dealing with the USDA side, right? USDA and APHIS, you're dealing with the actual growing side, and you're also dealing with the FDA and the food side.
Mhm.
So there's a number of different interacting things, and sometimes those don't interact well. For example, with allergens, we've seen companies have issues with allergens and then having to ring fence things. So there's quite a lot of challenges on that side. But I think it's really going to come down to seeing real commercial traction in the market, and then when that happens, I think it opens up a lot of things.
Now, every breakthrough, it comes with its fair share of roadblocks. Would you say those regulatory aspects, they're the biggest challenges that you're facing, or are there others?
No, I think we've set up that we have some of our products that are much more regulatory constrained than others.
Mhm.
Um, for us, our biggest challenge, I think, we started off growing meat proteins when we first started, 2 or 3 years ago. So that was a big punch in the face. So our technology worked. We validated the technology. We were able to produce identical meat proteins in edible plants. Edible plants, I emphasize. But at the same time, the commercial market fell out from under us. Right, so we got sort of punched in the face pretty quickly, saying, "Oh, hey, you did a great job. Well done on the technology, but no market, buddy."
Yeah.
So I think that's always it could be a good wake up call, because it forces you to really think around your platform and say, "Wait, do we have a platform here, or is it just like a gimmick product?" So it really helped us in retrospect to really think through clearly around our platform and see the wider applications.
Mhm. Now, finally, if you could share one key takeaway about molecular farming and your company's role in the future of food and biotech, what would you want our readers to remember?
Yeah, I think again the potential of fundamental transformation. I think people don't realize how quickly and how vast agriculture could transform. It has a reputation of being slow moving, things like that. If you look at an older company that people don't like to talk about because it's very controversial, but if you look at Monsanto back in the day, and you look at GM in the U.S. and across the Americas, and how quick and how profound that adoption was throughout the agricultural industry, you're talking about 0 to 95% adoption in under 15 years in some
Mhm.
crops. So it changed entirely the dynamics of yield. It changed the dynamics of profit. It changed the supply chain through fundamental events in science. So there's no reason really that molecular farming shouldn't be on the same trajectory. It may take time, But once the formula is cracked for actually getting this out to the world at scale, the scaling potential is massive.
Mm-hmm. Well, look, Meir, thank you very much for joining us. It's been great to catch up with you, and we'll be following your developments very closely in the future, and hopefully we'll have an update soon.
Yeah, thank you so much. I'm a bit under the weather today. I apologize, but thank you so much. Much appreciated.
Yeah, well, I hate to hear you when you were feeling tip top. You sounded great. Cheers,
So
Meir.
appreciate it.